कैमरा देखने जरूरत नहीं.
Good morning everyone. Myself is Mayur Jawane. Today I am going to discuss with you some definition and one theorem about the modular characterization, which called as Redekind's criteria for modular lattice. So let's start. So firstly we see some definition, that is joint irreducible. Joint irreducible, it means if an element A belongs to L, uh, is called joint irreducible if A equals to B join C, then A equals to B or A equals to C. It means we have an element A belongs to L. L is a lattice, that called joint irreducible if A equals to B join C, then A equals to B or A equals to C is called as joint irreducible. Okay, same as.
So it is meaning that you cannot write that element as join of two distinct elements.
Yes.
Is that clear? That means you cannot reduce further. You cannot write A into join of smaller elements. Whenever you are writing like that, then one of them is equal to that. Is that clear? Yes.
Similarly for meet irreducible, an element A belongs to L is said to meet irreducible. What is the condition? Can you? A equals to B meets C. If then A equals to B or A equals to C. This is the meet irreducible. And one another definition is double irreducible. Double irreducible, it means same, an element A belongs to L said to be double irreducible if, what you can say, these two definition from this, these two definition related with this, can you say? Yes, is both join and meet irreducible. Okay, so these are the examples. Yes. Further we see one theorem on modular lattice.
You take one example. See, we will write suppose diamond, whatever we have seen so far, diamond and pentagon.
Example.
Right, suppose diamond lattice.
Okay, this is M3. Yes. Okay.
Okay.
So
now can you someone tell an element which is irreducible, join irreducible? Huh?
A equals to B join C.
That means we can't write A as, or whatever that element as, union of two disjoint join of two elements.
Yes.
Distinct other than A.
Yes.
Can we write A like that? Suppose element, this element.
Yes. You mean A equals to B join C, something like that?
No, not that B and C. It is different. Okay.
No, it is different.
Only thing is how you can write A here. A join 0.
Yes.
1 is equal to. So 1 is equal to A join C.
Yes.
Right. So and A and C are different from 1. So what can you say about 1? Is it join irreducible? It is reducible. Is this clear? Similarly 0 is meet. Okay, meet reducible. 0 is meet reducible. You can reduce 0 into further smaller. Are you following?
Yes.
Similarly 1 is join reducible. It is reducible, not irreducible. Is this clear? What about ABC? You can check that they are irreducibles. Are you following?
Yes.
Draw that quickly. N5 there. N5 pentagon. One side you will have 2 elements. What can you say about here? So here also you can see that you can't write, for example, A. In that diagram ABC, you cannot write join of two distinct elements,
Yes.
right? So you take other examples which we discussed earlier and try to find some are other than 0 and 1. Okay, so other than 0 and 1, you find some examples, some elements which are actually join irreducible and some are meet irreducible. Okay, so next class show me everyone that picture.
Okay. Now we are going to see one theorem on modular lattice, which is also called as Dedekind's criteria for a modular lattice. Okay, so theorem. Okay, the theorem statement state that if we have a lattice, modular lattice, then it does not contain n5 as a sublattice. It means
Yeah,
roughly I
first
draw
time.
one diagram that I can show. If diagram is not very well, but I want to show. Okay, this structure you can see this, only this is what our pentagon n5, and this is whole is a lattice. So whole lattice I called as suppose L. Okay, and n5 is a sublattice. Okay, so if this condition n5 is a sublattice of n5, then this whole lattice is a not modular lattice. This is going to be proved in this theorem. Okay, so theorem statement, if L is modular lattice if and only if it does not contain n5, which means pentagon as a sublattice. Okay, this proof is we are constructed using a contradiction method. So firstly we proof. Firstly we say that if
So is M3 modular from this statement? Huh?
M3, what you can say about M3, is it modular or not?
Why? because it doesn't contain that n5, right? You can see that. Yes or no?
Yes. It means if we have a lattice and that contain n5, that not going to be modular. Other than that, there must be a modular. Okay.
It is if and only if statement.
Yes.
If it is not there, then it is modular.
Yes. Yes. Okay. So if L is modular, म्हणजे जेव्हा जेव्हा आपला L हा जर मॉड्युलर असेल तेव्हा आपण N5 बद्दल काय सांगू शकतो? मग L चा सबलॅटिस N5 होईल का त्या केसला? कारण की आपली स्टेटमेंट काय म्हणते की जर N5 जर लॅटिसचा सबलॅटिस झाला तर ते मॉड्युलर नसणार आहे. ओके. सो सिन्स
वो प्रूव्ह करना है ना.
हा हा पण आता L आपण मॉड्युलर धरला, मग आपण इथं काय म्हणू शकतो इथं? सिन्स N5 इज नॉट कंटेन इन
That you have to prove, na.
yes but since N5 is not okay, we want to prove, but no, we know N5 is not modular. Okay. N5 is not modular. Okay, since N5 is not modular, yes, N5 is not modular, then is N5 is a sublattice. A sublattice of modular lattice is again a sublattice. Okay.
Modular.
Yes,
That means L cannot be.
सबलेट म्हणजे आपला N5 मॉड्युलर नाही आपल्याला माहिती आहे. मग हा L चा हे होईल का, म्हणजे काय म्हणतात त्याला?
L cannot be a modular lattice if it contains, right?
हा yes.
Because there will be at least 3 elements in N5 which does not satisfy modular property, but there are also elements of L, so L cannot be modular. Are you following?
Yes. It means yet.
So you erase that first one, first line you erase.
Which
Above. That you remove. Since N5 is not modular,
it cannot be contained in
modular lattice.
Contain in modular lattice, modular, which is L. Okay.
So you write in more, that is if next line, if N5 is contained in L, if N5 is contained in L, then L is not modular. Yes or no?
If
N5 is contained in subset, you write notation subset of L. Obviously then L is not modular. Yes. Then this is clear, right? L is not modular.
बाय विच म्हणजे हे कशाहून कॉन्ट्राडिक्शन, म्हणजे सॉरी कशाहून फॉल्स आहे तर सबलॅटिस
is modular.
मॉड्युलर म्हणजे आपण N5 आता जर सबसेट घेतला, सॉरी सबलॅटिस घेतला तर त्या स्टेटमेंट नुसार ते मॉड्युलर होत नाही. ओके.
So that proves one way that if L is modular, N5 can't be contained in L.
Suppose we assume that suppose L is not modular.
We are proving converse, right?
Yes.
Converse part.
Yes.
So right there also N5 is not contained in L.
Okay. Here.
N5 is symbol.
Okay.
And we are supposed to prove L is modular, and we are proving by contradiction. Yes.
Suppose L is not modular. Then we know modular lattice definition. If L is modular, then if then for all x is greater than equal to z, x meet with z join y equals to x meet y join z. Is it correct? Why? No, no, no.
X meet
It
Y
is
join
correct.
Z. Here. X meet Y, left side. X meet Y,
X
meet
meet Y
Y.
here. Right.
And Z.
Okay. Yes. So this is the definition of modular lattice. So we assuming that L is not modular. Okay. So L is not modular. It means what? Yes. Exactly. So what?
Here is this part, no problem.
No.
Enter it.
So
That,
what we
that
can.
theorem also you remove. You can.
Yes. So we want to L is not modular. Then we have some elements which not satisfy this property. Okay. So there exist A, B, C belongs to L with A is greater than equal to C. Okay. A is greater than equal to C. This is our X. This is your Y, and this is your Z. Okay. Yes. Okay. So what? A
A meet B.
A meet B join with C is not equal to A meet, okay, which means this L is not modular, therefore that property it also not satisfies. Okay. So from this what we can say, A meet C is less than equal to A. Is it correct? Can we write this as this? Yes, and we have already taken uh,
No,
is what?
why? What you want to say? Because A is greater than equal to C. A meet C is C only, na?
A meets C. One second.
You want A meet B, na?
A meets C बरोबर आहे सर. A meets C
ठीक है, right? What you right?
सॉरी A meets C पाहिजे इथं B पाहिजे असं आहे. हे जे नाही एलिमेंट हे X Z Y असं आहे. A is
Then there you write A.
A is greater than equal to B.
There.
Yes. From this
One second.
A meet बरोबर
That is correct.
बरोबर आहे ना.
How?
त्याला एक नंबर देऊ. आता यावरून असं A meet C जर असाल तर त्याला आपण लिहू शकतो म्हणजेच कसं, इफ वी हॅव X meet Y is less than equal to X, then what we can say about X is less than equal to Y. Okay. So from this follows. Yes. So then
What you are trying to prove?
I want to take a join, and then I want to this statement is less than this, like strictly less than. That
That is always true, na? We have proved that lemma, right?
No, but I want to prove here. Improve is
Okay.
that way. Okay. So
you write that as A greater instead of A greater than B, B less than or equal to A. Right. So
if we take this to A,
that is correct. You just write B less than or equal to A. It is same. B less than or equal to, not greater. B less than or equal to A. Now take the meet join.
A meets C join with B less than equal to A. Only A. Okay. So again, what we can write this, A meets C less than equal to C. Can we write? Yes. And his C is less than equal to B join C. Can I write? Because of if we have X join Y, okay, is equal to X, then Y must be less than equal to X. From this we can write C is less than equal to B join C. Yes. Okay, and B is also less than equal to B join C. Yes. So take this and this join. So A meet C join B less than equal to B join C. So this star, this star. Take these two equations meet. Okay. So what we get? What we get here? These two statement. What? A meet C join with B. If I take A meet C join with B and meet again this element means X meet X. What is that? X. So this side is equal means same. That's why I am directly taken as A meet C join B. Okay. And right hand side will be A meet. Okay, but our first equation what is say that if this A meet C join B is not equal to A meet B join C, so this can be written as A meet C join B is strictly less than A meet B join C. Number as 3, and I think this number is 2. Okay. Now our whole proof is going on this equation. Okay. So we are what we do first. L is not modular. Okay. We are assuming that. What? This? A? A? Okay. X meet Y equals to X.
No, x meet y is less than or equal to x, na? Y
Okay.
equal
Okay.
to.
Okay.
And
When
it
this
is always,
possible? When this possible?
it is always true, na? X meet y is always less than or equal to x.
Okay, and B joins C. Sorry, C is less than always less than B joins C. It means if you have here B and here C, what is the meet? Yes, C. But C is always less than means आपण त्याचा सुप्रीम घ्यायलो. सुप्रीम त्या कधी पण त्याच्यापेक्षा मोठाच असणार आहे ना. हे याच्यापेक्षा मोठा असणार आहे ना. त्याच्यामुळे आपण सी याच्यापेक्षा लहान घेतला. ओके, मग तिथं तेच केलं फक्त आपण. So we want to prove what n5 is a pentagon. If we prove n5 is a pentagon, our assumption will be wrong. We assuming that n5 does not contain in L. Okay, if we prove n5 is pentagon, which then our assumption become wrong, and we then say that L is modular. Okay, so we draw diagram. Let's take B meet C. Is it B meet C or B joins C? B joins C, I think. Here C. Here A meet C. Here B. Here B. Okay. So this diagram we know means structure is no n5, but our aim is to prove it is n5. It is pentagon, and we know pentagon is not a modular lattice. Okay. So our aim is it is n5. Okay, so we prove some properties on that. First, claim A meets C is less than U. Second one, B is less than B join C. Third one is C A meets C is less than C. Fourth one is C is less than B, join C. Okay. Fifth one is uh, C is not comparable to U and C is not comparable to V. This sign is not comparable. Okay. This means not comparable. Okay. And sixth one is uh, C meet V equals to C meet U equals to A meet C, and 7 what C meet U equals to C meet V equals to B, sorry, join C join U equals to C join U equals to B join U, B join C. If we prove these properties, then automatically it our aim is achieved. Okay, so we prove first, one by one we see the proof. First claim is A meet C is less than U. Okay. So
What is your U and V? You have not mentioned what is your U and V.
okay,
Whatever
sorry,
that
sorry.
you write there only above. You
Yes,
write U is
we
equal to
we earlier got this equation. A meet C join with B equals to less than, strictly less than. A meet B join C. Okay, this equation is very important.
so one you call it as U or the other one is V, right?
Yes, so this is part is U and this part is called as V. Okay, so on that we can prove A meets C is less than U. If we take A meets C is less than equal to U, it is obvious. Can you say?
Because you write U is equal to join of those two, right?
Yes.
A meets C join B.
Yes. So clearly it is obvious. So what is the value of U? What? A meet C join with B. Okay. From that, suppose A meet C equals to U, which equals to A meet C join with B. Suppose I take this. Okay. From this to
When we say that meet of join of two elements is one element, the right? That A meets C should be bigger than the other one.
yes,
Or no?
because of join. Yes.
You are so right. What you will get from that?
Here.
Next step.
Yes. It implies.
So what is the relation between B and A meets C?
Yes. What?
B should be less than or equal to A
A
meets
meets
C.
C. Right. B is less than equal to A meets C. Okay. Okay. This is true. And also it is less than equal to C. This is obvious. Okay. From that we can say B is also less than equal to C. Because of this quantity is less than this, so this is also less than this. Okay. So B is less than equal to C. From that, what we can say? Yes. Okay. Now, if we take A meet B join C. No. Oh, one second. Yes. A meet C join B. A meet C what?
See, B is less than or equal to C. So therefore, what is B join C? C.
B join C equals to
C.
C. Yes.
So now you check that third one, you get contradiction.
Yes. This one.
So what you will get? A meets C
Directly I take A meets C,
Left hand side it is A meets C. Okay.
join B.
That is same as A meets C we have assumed there, right? Suppose. So you remove that join B.
Which one?
You remove, strictly less than. What is A meet B join C? Is same as A meet C.
A meets C.
This
Yes,
is
yes.
contradiction. A meet
So-
C join is less than A meet C we are getting.
Which is contradiction. So this assumption is our wrong. So that's why A meets C is strictly less than U. Okay. Similarly, we can going to prove second one.
If second one is similar, then you can skip. And is there any different one? Proving second one. Is it similar to one?
Similar look like the lower pass.
Then you can prove third one. Whether you want to prove second one? Huh?
Okay. We are going to for third one. A meets C less than C. So on that, what we can write? Clearly, A meets C is less than or equal to C. Yes. And suppose
If they are equal, suppose if they are equal, what you will
yes,
get?
A meets C equals to C, right? So what we can say?
What is relation between A and C? C should be smaller, right? But what we started with A, B, C? Huh?
C is less than
Where
equal.
you get contradiction?
नाही खालच्या स्टेपला कॉन्ट्रॅडिक्शन भेटते C less than equal to A. A meets C. Okay, एक second. A meets C join B. Okay. अच्छा. Okay. This statement. A meets C join B. From that, what we can write here? What? C join B. Okay. But what is this? This is A meets C join B less than A meets B join C less than equal to C join C. Can I write this as a this? Can I write this way? Yeah. So we are assuming this. Equation third says that this quantity is less than, strictly less than this. Okay. But this quantity, the answer is B union C. B union C is strictly less than what? B union C, which is what? Which is contradiction. So we don't take C as a we don't take C is less than equal to A. Okay, this is contradiction. I write here C is less than equal to A, then it is contradiction. Okay. So similar proof for this also. Can I write?
Yes. Then you prove next one. No, it is similar, right? Next main thing is the fifth one. You try to prove they are not parallel.
Okay. Fifth one, claim. See, firstly we prove this. Okay.
What is meant by saying not parallel? They are not comparable.
Not comparable means no relation on no
it is
relation
not C is not less than or equal to U, or U is not less than or equal to C.
Okay. If we take C is less than equal to U. Okay. Suppose. Then what is U? A meet join with B. Okay. From that, what we can say? C is less than U. Okay. Hmm. Yes. C is no. Okay. Okay. We earlier write one definition. There exists A, B, C belongs to L. Then A meets C is less than equal to A, and B is also less than A. We know this. So from this, since B is less than equal to A and A meets C is less than equal to A. Okay. From that, what we can say this A meet C join B is less than equal to A. Yes, we can write, but what we can assume C is less than equal to U. Nothing but C is less than equal to A. Okay. So C is less than equal to A. What we get? Contradiction. So this is contradiction. Okay. So C here can I write? Sorry. C is not comparable to U. Similarly, we show suppose U is less than equal to C. Okay. So same A meet C join B is less than equal to C. Mm, then A meet yes. B is less than A meet C. B is less than A meet C is less than C. Can I write? Join join आहे ना मग B याच्यापेक्षा लहान येईल. What? A meets C?
But why B is less than or equal to A meets C? We know B is less than or equal to A, right?
Okay.
What do you want to prove?
B is less than. Okay, right. Now we can write. Okay. From that, B is less than equal to C. But in if we going to prove this, uh, so there is one contradiction. If take B is less than equal to C, then it is contradiction in this proof. That's why we don't write here. So B is not comparable to U, which is contradiction. Okay. So, and similarly for C is not comparable to B. C. So take C. C. C is less than equal to what is the value of B? A meet B join C. Okay. Uh, from this, what we can write here? What less than? C. Yes.
The right hand side is meet of two elements, so it is less than or equal to individual or not.
Yes.
There only you write next step, there only above.
Here.
That is clearly less than or equal to A, but which is a contradiction. We already proved that C can't be less than or equal
Yes.
to
Yes.
A.
Yes. Which means C is not okay. Right. So again, if we take this what B and C. Here we get, I think, C. From this, what we, how to prove this? This is contradict. What we can say about this? Yeah. Yes. A is less than. A is less than equal to C. No. No. No.
What is the relation between A, B and C?
What we can write this?
A is
We
greater
want to
than or equal to
contradiction.
B, right? A is greater than or equal to B.
So A is greater than equal to. Sorry.
B is less than or equal to A.
Okay. Then what we can say? B.
Huh?
One second. I want to.
You want to get some contradiction, right? And also you write B is less than or equal to B join C. B is less than or equal to B join C, na?
C is less than. Okay.
Don't worry, go and write there. B is less than or equal to B join C. So therefore it is less than or
No,
equal
sir.
to.
Directly we can say. Okay. We know this. Okay. So U is less than B, less than equal to C. Okay. But U is not comparable to C. Then V is not comparable to C. This is contradiction. This is proof. Okay.
Without this also you can prove it is not a difficult one. Without using U also you can prove. You can show that B is less than or equal to C, which is a contradiction. Okay.
Okay. Now sixth one. C. Sorry. If we take this meet and this meet, what we can say? A meet C with U meet C means A meet C from 1 and 3 meet with A meet C equals to,
Not equal.
sorry, less than equal to U
Strictly less than.
U meet C, less than equal to U meet C. This is obvious from 1 and 3. Okay. From 1 and 3 we can write that. Yes.
It is same as left side A meet C, na? Left side.
A meet C. Okay. This. Okay. Now we want to prove they are equal, means we want to prove U meet C is also less than A meet C. This want to prove. Okay. So A meet C less than equal to. Okay. What is the value of U? A. What is that? Join. Nice. Sorry. I went. Sorry. C. Okay. Uh, what we can write?
Why you are writing this? Oh, that
Because
is.
this side going to equal to this.
Huh?
म्हणजे हे आपल्याला तिच्या इक्वल दाखवायचं.
So you simplify U meet C, na? Why you are simply writing A meet C?
U ही साइड घेतली आणि याला असं लिहू शकतो ना, म्हणजे U ची व्हॅल्यू इथे टाकली, त्याला मीट केला. आता अब्सॉर्प्शन प्रॉपर्टी नुसार आपण सॉल्व केलं तर
ठीक आहे, एक्सप्लेन.
ओके. ए मीट व्हॉट सर, एक मिनिट.
See, U is join of those two. Okay, U is join of A meet C and B. So obviously U is less than or equal to A meet C. So when you meet with C again, you erase this. You write U is equal to A meet C join B. So therefore, obviously, write next step less than or equal there only, which is less than or equal to what? A meets C. No,
Okay.
you cannot write that.
A,
It is not correct, right? That is not. It is greater than or equal to. Huh.
yes.
Erase that.
U meet C. Sorry.
Then
U meet C.
you try to meet with C.
U
You meet C.
means okay. Okay. Then A meet C. Meet C.
No, no.
Then what? U equals to A meet C. Join B get A meet C. If you take this, okay, we know by the definition A meet C is less than equal to A and B is less than equal to A, then this whole quantity is less than equal to A. From this, can I write this? Okay, so U is less than equal to A. If I take meet with C, so is less than equal to, okay. So ते झालं तर आपण यावरून काय करू शकतो आता? If I take U meet U meet C equals to A meet C, then okay, what is the value of A?
We have proved that just now, right? U meet C is equal to A meet C. Just now you
We
have
want to
proved.
prove now U meet C equals to A meet C. Okay, ते तो prove केला आपण.
Now you prove that it is equal to either C meet U or C meet V.
C meet V. C meet V, okay. U meet C. C meet V equals to what? कसं व्हायला व्हायचं?
You find C meet V value and show that it is equal to A meet C.
कळायला पाहिजे. A meet C आता हे A meet C less than U meet C.
You have proved U meet C is equal to A meet C. ये prove किया ना?
Yes.
यहाँ तक.
Yes.
Then you write this.
U meet C.
V meet C रे. V
V,
meet C.
oh,
रे.
right.
So you find value of V meet C.
Okay, right. V meet C is equals to
Right there. V meet C is equal to you erase that everything left side, right side, above.
this one.
Here, right below also you remove, erase that. Right clearly, no problem. Go slow.
What V meet C equals to A meet C.
That we have to prove that. We have to prove that, right?
Claim. Okay. So what can I write? Which? B meet C. Which value? What is that? A meet with C. Okay.
That you have to prove. You erase that right side.
Okay. So
now this is associative, na?
okay, म्हणजे
Join कहाँ से आए? Meet है ना?
okay, meet.
First, this left hand side you write bracket for this A meet B join C. That is your V.
Yes. So what we can say about A meet by absorption property, what is this? So is equal. Okay.
इतना confused क्यों होते हैं? See, these are all actually when you read it, you feel like you understood. Okay, so if you don't practice more time, then you will get confused. When you read, you feel like it is very easy. Okay, but when you are actually writing the proof, you will confuse. So that's why you have to practice this several times. Right?
Yes. Yes. Now we want to prove this.
Is it not similar? Prove one. Any one you prove.
We एक part.
Prove.
What if I take C join what G plus 2? Sir, what I did?
From second and 4, what you can say second and 4, C join V is less than or equal to B join C. Yes or no?
Yes.
You erase that. From second and 4, V join C is less than or equal to B join C. B join C. Right?
Yes. Now B join C is less than or equal to V join C.
You can prove that.
Yes. B join C is less than or equal to. We want to prove this.
Where, why you taken above V meet C? It is join C, na? V join C.
So A meet A meet C. But
Why it is A meet C?
no. सर तिथं फर्स्टली काय घेतलं तुम्ही?
अरे you should prepare more, huh?
Yes sir. असं घेतला V equals to A meet C join V is less than B join V join C केला. Okay. Sorry. If we take U equals to A meet C join with B and V equals to A meet B join C. Okay. So B join is less than or equal to B join C. Can I write? This part is less than or equal to B join C. So from that B is less than or equal to B join C. Okay.
V join C is less than or equal to B join C.
Yes. So
So you join C.
take a join with C in both sides. B join C is less than or equal to B join C join C. But what is this? B join C only and V join C. Okay. This we get. So after that, here I can write. Now we want to prove now V join C. V join
See, U is less than V, right there. U is less than V, that is given, right?
U.
U less than V, that is given. U is less than V. So therefore U join C is less than or equal to U join C less than or equal to V join C. Left hand side it is U. U U join C is less than or equal to
V join
V
C.
join C, and V join C is less than or equal to B join C. You write there only. So if you want to prove they are equal, it is enough if you prove that B join C is less than or equal to U join C. Okay, so you write their claim B join C is less than or equal to U join C.
C. So U join C. U ची व्हॅल्यू टाकून करा.
What is that value? A meets C, join B, join C.
Join
C.
C. Okay.
It is join of
alternate म्हणजे change.
join B join C. C also you take that side. B join C. A meets C, join
A meet
meets C.
B join.
You have not prepared well. That it clearly it says. This is simply A meets C, join with B joins C. Yes or no? So this one is join of these two. That means what? Obviously it is bigger than this one or not? So therefore it is bigger than B join C. So that is what we are supposed to prove. U join C is bigger than B join C. So from this what you know? So just now we proved that this is less than or equal to what? B join C is less than or equal to U join C. Now if you combine all four, what you will get? All are equal. Yes or no?
Yes.
So that shows that this 7. Is this clear? Yes?
Yes, sir.
So that concludes what? That this whatever diagram we have constructed, it is N5
N5.
and which is contained in L. That is a contradiction. Yes or no?
So that contradicts or proves. From this, our N5, what we can say?
N5 is contained in L. Just now we have proved that, right? N5 is contained in L. That is a contradiction.
Yes, contradiction.
And all this contradiction arises because of what? We have assumed that our L is not modular. So L has to be modular. Okay, good.
Yes.